BTEC Applied Science, Unit 5, Physics, and this is the second section of the Unit 5 Physics, and it's about materials. And this is the first video, material properties. There's a list of material properties, and they have very definite meanings, and you need to learn them. There could be a question: what does strength mean? What does stiffness mean? There's three metals here. It'll be mostly talking about a metal: copper, steel, aluminium. And you need to know what these words mean: strength, stiffness, brittle or tough, which is the opposite, malleable, ductile, and density as well, we're going to talk about. So strength. A strong material needs a large force to break it. Basically, if a material is strong, then you need a big force to break it. For example, steel. The cables on this suspension bridge are made of steel for a number of reasons. One reason is because steel is strong. If lots of lorries drive over this bridge, we don't want the cables to break. Okay, so steel is strong. It needs a large force to break it. One of the reasons you wouldn't make them out of copper is because copper isn't very strong. So copper cables would possibly break. So a strong strength is resistance to breaking. A strong material needs a large force to break it. Now, stiffness is resistance to deformation. A stiff material does not deform very much. For example, if you stretch it, then it doesn't extend very much. If you squash it, then it doesn't squash very much. Mostly we'll be talking about either tensile stiffness or compressive stiffness. There are other types. If it was a beam, then it could be bending, or it could be torsional stiffness, but basically either tension or compression, stretching or squashing. Don't get strength and stiffness confused. Something like rubber isn't a stiff material by any means, but it is actually quite strong. If rubber wasn't strong, then you wouldn't jump off a bridge tied to a piece of rubber when you go bungee jumping. Okay, steel is a stiff material. Rubber isn't stiff. If we're talking about an object, then such as a wire or a spring, then K is the stiffness. If we're talking about a material such as steel or copper or rubber, then we use this capital E. It's called the Young's modulus, and there'll be videos on these later. The next video is about stiffness. Brittle. A brittle material is prone to cracking. It will crack easily. A tough materials are resistant to cracking. So brittle and tough are all about cracking. Cast iron is strong and stiff, but it is prone to cracking. If you get something made out of cast iron, such as an engine block, and you give it a good smack with a hammer, then it might crack. Okay, glass is a very brittle material. Something like wrought iron, such as this horseshoe, is tough. It doesn't crack easily. So brittle, prone to cracking; tough, resistant to cracking. Malleable means it can be hammered into shape. For example, copper and iron are malleable. If you think about it, another name for a hammer is a mallet. So malleable materials can be hammered into shape. Ductile. This has a very specific meaning. Ductile materials can be drawn into a wire. If you grab the ends of it and put it in tension, then it'll get thinner and thinner in the middle. Okay, it's drawing into a wire. You draw it into a wire. Copper and gold are ductile materials. The first photo shows making copper wire by stretching it. The second photo shows some precious metals like silver and gold, which are used in jewellery. They are ductile materials. They can be drawn into wire. Then lastly, density. Density is mass per unit volume, kilograms per metre cubed. I can imagine you might get a question where it's grams per centimetre cubed, but I doubt it. Kilograms per metre cubed. For density, we use this Greek letter rho, R-H-O, rho, and then rho equals M over V, mass divided by volume. So density is mass divided by volume, kilograms per metre cubed. For example, the density of aluminium is 2,710 kilograms per metre cubed. If you compare that with the density of uranium, that's 18,900 kilograms per metre cubed. It's about 6 or 7 times bigger. Aeroplanes are made of aluminium, because if you make an aeroplane out of aluminium, then its mass will be relatively small and it can get in the air. These are shells made of depleted uranium. Why do we make like shells, like tank shells, out of depleted uranium? Because then they're very heavy, and then when they smack into things, they do a lot of damage. So density is mass per unit volume. Here's some questions. Write down the definition of each of these. Strength, stiffness, brittle, tough, malleable, ductile, dense. Write down the definition. Be able to write down exactly what each of these means. Then here's a little sum for you to do. A block of iron has a volume of 0.15 meters cubed and a mass of 1,180 kilograms. Calculate the density of iron from this. And I'm not going to do it. I've said, now look up the density of iron on Tinternet and check your answer.